All right, guys, welcome back. I'm gonna be continuing with our lesson. We're talking about isomers, and the third isomer type that we have is functional isomers. Now, functional isomers I'm gonna show you an example. Now, this is a ketone. Butyl butane 2 oh however, with the same amount of carbons, the hydrogens, we can have something of this sort. Now, this is an aldehyde. Butanol. All right. Now, I'm just gonna explain a little bit of how the naming system works. We have the so-called root names. Names. We also have prefixes. Pre means before. Okay, the prefixes that we're gonna use. We've already discussed the root names. Your alkanes, ANE, your ENE, up to so forth. Now with hydrocarbons, the first one is meth. Second one is earth. Prop. Number 3. Number 4, butte. Number 5, pent. Pent means 5. Number 6, X, 7, hept, 8, opt, 9, non, 10 is dec. All right. Now, what are the general rules that we normally follow when we do the naming? Number 1, identify the identify the homologous group. Now, how do you do that? You look at the presence of your oxygen, your hydroxyl groups, your halogens, and the structure. Number 2, you have to find the longest chain. And then name positions of carbons. So on this one, you must start naming where there's a nearest substitute. Now, by substitute, these are substitutes. Your oxygen, your hydroxyl, your halogens, and so on and so forth. All right. The other thing, also start where there is a double or triple bond. The main chain should form part of the ending of your name. Now, naming of the alkyl group group is alphabetic. Meaning ethyl comes before methyl if they are more than one branch of alkyl. All right, we're gonna move right along. I'm not gonna mention a lot of rules because on this chapter, we're gonna do a lot of examples. But it will be on the next segment. All right. Now we're gonna talk about the forces between the molecules. Intermolecular forces. Now, these intermolecular forces, they are the ones that determine the property, the physical property of your hydrocarbons. The intermolecular forces are not bond forces that, let's say, for instance, if you have methane. Now, these are intramolecular forces. But if I put another molecule, this force, the force in between these molecules, that's what we call intermolecular forces. Now, all the forces between molecules are called van der Waals. Van der Waals forces. Sorry. Now, within the group of van der Waals forces, we have three different groups. The first one is the induced dipole. So now with induced dipole, you have two molecules, two molecules that have very weak, that have zero or no forces in between them, but there is temporary shift of electrons that causes an imbalance, and it causes a little bit of a force between two molecules. Then there's the dipole dipole. So with dipole, it happens when there's a slightly positive and a slightly negative side of the molecule. slightly positive and slightly negative. So this may happen, let's say for instance, if you have two aldehydes, because the aldehydes, they have an oxygen ending. So the hydrogen portion of the aldehyde, if you have two aldehyde molecules, the hydrogen side of your aldehyde will slightly be will be attracted to the oxygen side, the aldehyde. But take note, this is not the type of van der Waals force that I'm going to explain under C. So under C, we have lastly hydrogen bonds. So now with hydrogen bonds, this is the bond between hydrogen and the hydroxyl group. So that's the attraction between the hydrogen and the hydroxyl group, which is your OH. So most famous example is the alcohol. So if you have two molecules of alcohol, here we will have a hydrogen bond. All right. Now, the weaker the stronger the force, the higher the boiling point, and the lower the vapor pressure. All right. So again, the longer the chain, the stronger the bonds. Now, the other thing is the smaller the mass, the lower the boiling point. Now, lastly, branched molecules have low boiling point. And that's about it. We're gonna move right along. Now we're gonna talk about the reactions. The reactions between hydrocarbons. All right. The reactions between hydrocarbons. The first type, the oxidation. As the name explains itself, if you take an alkane and add oxygen, you will get CO2 plus water. Then plus energy. All right. The second, now this is also called combustion. Combustion. Okay. Also called combustion. We also have substitution. With this one, obviously, something has to be substituted. Note that with oxidation, I used alkane as an example. Why? Because alkane is saturated. Saturated means there's only single bonds throughout. Substitution. A very good example, if a taxi is full, it means you can't add more passengers, but you can substitute, of course. So if you add a halogen, you can get a haloalkane plus one of the byproducts. Now, on the two halogens, we have one halogen substituted into the alkane chain, and then one was left. Number three, we have addition. As I've indicated, you can only add a passenger if the taxi is not full. Alkene plus hydrogen will give us an alkene. Note that alkene have a double bond. A double bond is unstable. Whenever you add hydrogen, it will break. It will break, and you will have a saturated hydrocarbon afterwards. Now, lastly, we have elimination. Name says it all. With elimination, you always need energy and or catalyst, because elimination takes a lot of energy. So now there's a rule that you need to follow. It's called the Markov-Nikov rule. Now it states that if an isomeric reagent is added to a symmetric molecule, to an asymmetric alkene, then the negative half of the reagent attached to the carbon with less hydrogen atoms. All right, for an example, one, two, three. All right, as you can see, if you add hydrochloric acid, HCl, what happened to this unsaturated compound? If we check here, this is the carbon with less hydrogens. It means the negative part of the reagent, which is your chloride, it will come and attach on this carbon because it has less hydrogen. So what we're gonna get is something of this sort. Let's see. Let's see. All right. Cl. This is where Cl will attach on this carbon. We also have hydrolysis. This is whereby you can add water to take out some of the atoms, some of the elements from the chain. So for instance, if you have a halo alkane, then you add water, you will get alcohol plus your hydrogen with a halogen. So the OH from the water will go and replace the halogen. The reason why it does so is because hydrogen bonds tend to replace any other bonds. Oh no, not hydrogen, sorry. The OH tends to form a very strong intramolecular force in the molecule. Now, moving right along, we have the so-called polymers. What are polymers? Repeated chains of monomers. Now, the longer the chain, the stronger the polymer. Again, they don't conduct electricity and heat. The other property, they thermoplastic polymers, soften when heated. And have long chains, long parallel chains that glide apart from each other, glide past each other, when heated. We also have thermal set. As the name says itself, once the chemical reaction takes place, the molecules are set in the same position. And on this one, it can be softened when heated. Since molecules cross-link. We also have the so-called polymerization. Polymerization, we have two types of polymerization. The first one, addition, polymerization. With addition polymerization, add the same monomer. For instance, if you add the ethyl, then you will have, this is how we write the notation for polymers. That ends then for, it shows that your chain is long and it may go up to infinity. And we also have condensation. Polymerization. And this one, polymers. Releases they releases water as products as a result. Now, if you go to if you go and check on some of the plastic packaging, there is these two symbols that you will see. LDPE. It stands for low density polyethylene. So the naming of a polymer is derived from the monomer that was used. So if you used ethene, then you're gonna have polyethylene. So now there's also HDPE, which is high density polyethylene. We also have polyesters. You have your Kevlar. I won't talk much about polyesters, but it's a similar process. All right, guys. Thank you so much for your ears. I'll see you on the next segment. Please don't forget to like and subscribe to make sure that we grow our community. If you feel like most of the segment of the video helped you, please share to the next person. All right. Thanks. Sure.